In this video, we'll be solving this problem of Pascal triangle. We have solved this problem previously, but this problem is slightly different. So in this problem, we are given row index. It is an integer, yes, and we want to return the row indexed entire row of the Pascal triangle. Previously, we had to return the entire triangle, but right now we only have to return a row of this Pascal triangle. And this is a zero indexed thing. The row is indexed starting from 0. And so you can see the example here. So if row index is 3, I want to return the fourth row, right? 0, 1, 2, 3. This particular row, I want to return 1, 3, 3, 1. That's what exactly is the output. That makes sense. So on the right, there is the solution, but before we get into that solution, let's go and understand the patterns in Pascal triangle, right? So this is a Pascal triangle, right? The row index starts from 0 all the way to 4 in this case. And something here, like I've changed this triangle, these elements in this form. I pushed everything on the left. That's because our arrays looks something like this if we had to write them down. Now there's a pattern, like let's say this value, right? To get this value, I'm adding 1, whatever value is on the left, this value with this value 1 to get 2. So to get 3, I'm adding 1, that's the value on the left, to 2 to get 3. Similarly, whatever is on the left of 3, that's 1. If I add that, I get the value 4. That's a pattern we have detected. Now to do that, I have actually written a solution that does exactly that. In this case, I first initialize row. And row is a list, basically list, and this list has ones initialized in them, and there are row index plus 1 values. The reason I'm doing this is because for any row index, let's say 2, when row index is 2, there are 3 elements. When row index is 4, there are 5 elements, just one more value. So that's why the number of elements in the row is simply row index plus 1, right? And then I have two nested loops. The first loop iterates different rows, just like previously, and the second loop in this loops iterates different elements in that particular row. And the first thing I'm doing is checking if that particular value in the Pascal triangle is edge value or not. If it's edge value, we know that's going to be it has to be 1. But in this case, we have already initialized all the values to 1, so we don't have to do anything there. We just have to check if they are not edge values. If they're not edge values, then what I'm doing here is that to get the value at jth position, I'm adding the value that is on the left hand side with the current value to get an updated value at the position j. That's what we actually detected, the pattern we have detected in Pascal triangle. So let me start putting row index 0 and start running this code. So at row index 0, it should be 1. That's fine. Let's go row index 1. Let's run it. It's 1 1. That is perfectly fine. Let's go to 2. That is also perfectly fine. In fact, this is not the Pascal triangle we should be looking at. This is the one. So let's again do 3. When you run 3, it's 1 3 4. It should be 1 3 3 1, but it's 1 3 4 1. So something is not right. Let's go 4. And again 1 4 6 4 1. That should be the values, but we are getting 1 4 8 9 1. So what's going around, right? Let's go back to this triangle and see. So these are the values that are mistaken by our program here, the 4, the 8, and 9. Let's see why is this 4. So to get this 4, I have to add 2 plus 1, and that should be 3, but we are getting 4. So what's the problem, right? The problem here is that you can see where the second loop is running from left to right. And when we are running from left to right, this value 2 is already updated to 3, right? So when I'm adding 1 plus 2, whatever's on its left, it's not adding 2 but add 3. So 3 plus 1 is 4. So our program has a bug. How to fix that? So that's the problem we have. Now to fix this, it is a very simple problem. You see, we are updating our values from left to right using this loop, right? And we need a value from left side. So if you're moving from left to right and we need a value of left that is that should not be updated, what if we move from if we update our values from right to left? That way the left values are not yet updated, right? So all I have to do is to use this loop, yes, to use this inner loop, but from in the reversed order. That's what we have done here. You can see the inner loop, I am iterating from ith position all the way to 0 in reverse order. You can compare that, see, that's all I have to do, and that's the same code, right? So if I run it, it should pass all the test cases, and this problem should be fine. Let's see. Yes, we are definitely fine. In fact, in this problem, I think I did not mention, but there's a follow-up note here. It says that could you optimize your algorithm to run in O of rowIndex extra spaces? And in this problem, we are not storing each and every row, just the row we want to return back. And that's this row. We are not allocating more space than we need. I think the space complexity for this program is O of rowIndex plus 1, because we have one more element here, but yeah, we're pretty close to this. So that's the solution. Yeah, thank you for watching.